Hello everyone. In this video, I'll show you how to simulate a BJT based vital current source or current mirror. So, first of all, we will design the circuit for a specific output current and then we will perform the simulation on the multisim using parametric analysis to test the output current for different values of resistors. So let's get started. And we can see that here is the circuit diagram and here is the analysis of this circuit, right? So we can move towards the calculation of the resistor values. So for the reference resistors of 10 kilo ohm, this is how much current we will have in the I reference branch. Okay, reference branch. Alright, so this is the value of RE to get an output current of 1 milliamp in the second transistor. Okay, so here we will have a reference current that will be decided based on the resistor instead of this current source, and then on the output side we will design this value RE to get 1 milliampere current at the output. So now let's simulate it. So go to Multisim and select the transistor, that is an NPN transistor, and similarly we need another transistor, then we need resistors. Go to basics, then resistor and place it here, as well as copy this and place it here as well to design for the specific reference current. Okay, then we need source, that is the DC power source, and then we need a ground, and definitely we will be needed an output resistor. And then let's connect all the components together like that, and this one can be flipped horizontally. So we also need to have this connection for the current mirror, and this is our current mirror circuit, and obviously we need another ground here. So suppose this is the RC resistor, that is the output resistor, and this is RE, and I can decide this value that and put it equal to 2.66, that is what we have calculated, and this one was 10 kilo ohms. And now let's place a current probe at the input side as well as at the output side, right? So now let's simulate it, and we can see that this is very close to 1.13 milliamps. That is what we have designed in this document. So it is 1.13 milliamperes, and the output current should be 1 milliamps, but here we have very close to 1 milliampere, that is 993 microamps. Alright, so now let's change the resistor value to 1 ohms only. So by changing the value to 1 ohm, we can again simulate it, and you can see that the current value at the output is still 993 microamps. Similarly, we can change this to 10 kilo ohms and then again observe the value, that is still 993 microamperes. So ideally, how much this value can be increased to have the constant current? So it depends on the mode of operation of the BJT transistor. For example, for the current mirror to work perfectly, we need to operate the two transistors in the active mode of operation. So obviously if we change this resistor to, let's say, 12 kilo ohm, so that means the total resistance in this path is 12 kilo ohm plus 2.66 ohms, that is greater than 12 kilo ohms, right? But the voltage source is 12 volt and the output current that we are expecting is 1 milliamp. So that means 12, more than 12 volts will be required, and hence the transistor will be in saturation, and that is why you will no longer see a constant current at the output. So let's see it. So here you can see that it has slightly decreased. Now further increasing this value to, let's suppose, 36 kilo ohms, we can see that the current source value has, the output current value has been changed a lot. So in order to perform parametric analysis in Multisim, what we can do, we can go to simulation settings, and then here is the parameter sweep. So we can click on that. Then we need to have a parametric variable, that is the resistor, and then select the corresponding resistor, that is our RC. And then what we want is the value, that is the resistance, as a parameter, that is the current value is 36. So we want to start it from the 0 kilo ohm or 0 ohms, and we want to have the extreme value equals to 36 kilo ohms. So the number of points can be 36, so that there is almost 1k increment in the points. And the sweep variation type is linear. Here it is the DC operating point, because we want the DC analysis. And then in the output, what we want to see the current in the RC resistor. So this is what we want to observe. Okay, so let's run it, and here you can see this is the parametric result, that is current versus resistance. So as you increase the resistance in the output, you will see a change in the current. So you can see that if I put a cursor, so at this point I observe a constant current. So it is starting from approximately 1 kilo ohm, and then it is increasing, it is constant up to approximately 11 point something kilo ohms, and then after that it starts decreasing, right? So in this path, in this time interval, you can see that there is an sudden decrease from 1.8 milliamps to 1 milliamps. So that is also suggesting that from 0 ohms it will be conducting a very high current, and because of that you will also see that the current mirror is not working perfectly. So there is some margin on the lower side, as well as there is some margin on the higher side. So this is how we perform parametric sweep or parametric analysis in Multisim. Thank you for today.